All right. Yeah. Let's do this again. I'm not seeing the thing.
Oh, I see what you mean. Okay. 5.
All right. How was your summer, man?
My summer was great. I picked up all kinds of things from my locker.
Holy, look at that.
I
eh?
know.
That's
You're
awesome.
not gonna believe what I have here.
I just have this stuff. It's just the
Well,
regular
get her
stuff.
in there. Now, I don't want anyone to steal these. I actually picked up collectible commemorative Star Trek The Next Generation Bridge Crew
I remember you
in
getting these.
China form. That's Dr. Crusher. We
Yeah.
got Jean-Luc Picard. He's coming
The
back.
man
huh?
himself. He is coming.
Yeah, we've got some Data and Geordi, so I
Okay.
really need these to be secured.
Put them in your locker, man, because
Yeah.
that's the safest place for them.
I think so.
I got just your trusty makey, some aluminum.
Do you think it's a
foil.
good idea for Captain Picard and Dr. Crusher to be in the same locker
I
together?
don't know. Maybe you should put them on separate.
I'm going to put them in separate shelves just to practice safe locker storage. Yeah. Oh, and I've got a makey markers and some aluminum foil.
That's great.
These are all important supplies to have in your locker. Woo! All right.
So you had a good summer, eh?
You know what? It was a great summer.
Wasn't it?
I spent a lot of time with family, and but I think it's important that we talk about our Brilliant Labs family.
That's right. Our Brilliant Labs family grew this summer. We had an incredible amount of staff working away at summer camps and things. I think it was an awesome summer.
Yeah.
All over Atlantic Canada.
Yeah, it was a great summer.
Yeah.
We haven't said welcome yet to our viewers.
Oh,
So
yeah.
welcome
Look
back
at
to the
that.
first YouTube Live. Welcome back to a brand new school year and the first YouTube Live of what we hope to have a few coming your way this year.
That's right. Yeah.
As Ko was saying, it was a great summer for summer camp. I actually took a little time and made a video intro here to get us ready to talk about it. Do.
So we had summer camps all over New Brunswick, Newfoundland, Nova Scotia, PEI, running all summer long, covering a huge amount of area and allowing us to do summer camps all over the Atlantic provinces.
Yeah.
It was awesome.
From Labrador to Newfoundland to Nova Scotia, Cape Breton, PEI, and here in New Brunswick, we had 7 different camps running, and thousands of students were able to come through our libraries and our community partners and participate in a pretty fun time.
Yeah, it was pretty cool.
Oh, that's good. Well, you know what? And I completely forgot to show the slideshow as we were talking about it. A couple of the highlights that came from summer camp. And our social media really blew up this summer with, or took off this summer, particularly around Rocket Day.
That was a good one.
So what
man.
was Rocket Day all about?
Rocket Day was a cool initiative that we started this summer, and it was an Atlantic-wide event where we had a number of our different locations participate in what we called Rocket Day. And so the challenge was, for the most part, to build and launch rockets as community events. And so we hosted these community events all over Atlantic Canada, and we're seeing some footage of some of them now. It was really cool because we had lots of people from the community turn out and participate in activities that related to rocketry and astronomy. And they also at certain locations got to build and launch rockets too. It was super cool.
That's amazing.
Yeah.
And if I understand it correctly, like this was our Brilliant Labs kickoff event, because this year, all year, we're going to have a space overtone or an undertone because it's the commemorative, it's the 50-year anniversary of the moon landing.
That's right. Yeah. So
Cool.
we're kind of going on that, as well as a lot of other organizations. We're kind of playing on that too, and really celebrating that huge momentous event. Right.
Awesome.
Yeah.
And I'm sure there will be some space-oriented activities coming your way. But fast forwarding to today, or coming back to present, speaking about activities that you can do in your classroom, we put together something that I think your students can definitely use. You can use because your locker is still open and vulnerable to all kinds of nefarious activity.
Oh, you just wait.
All right. So what are we making today?
We're making a locker alarm.
What?
Very exciting.
I think I actually have an intro for that.
Oh, there we
Boom!
go. Locker alarm.
Locker alarm. All right. Well, listen, my stuff's already in my locker.
Yeah, and you've got to get to class.
I got to get to
right?
class. I've
Yeah.
got a calculus class that I have to get
Oh,
up
boy.
to, right? We're
Alright.
rotating some three-dimensional objects around an axis or something like that.
You don't want to be late for lab.
I'm not very good at it. Anyway, we'll see you up there.
All right, see ya. All right, guys, before I leave for class, I'm going to do something super cool. I'm going to actually set my alarm because I don't want anybody stealing my stuff. See if I can get in here. All right. See you in a bit. Hey, get back here.
What are you doing?
What was that? Someone tried to get into my locker.
Ah! Someone did get into my locker. Beverly's got. Oh, Beverly's still there. Data's gone.
Oh, no.
Lieutenant Commander Data.
What are we going to do?
I don't know. I wish I had your locker alarm.
Oh,
It would be even
cool.
better if you actually put a lock on your locker.
That's true. Maybe I should do that next
But you know
time.
what? Many middle school students, they don't lock their locker anyway. So perhaps this is an innovation that they can integrate into their locker.
You're right, yeah, and maybe I can help you out, eh?
Yeah, please.
So the locker alarm really is just a microbit-enabled locker alarm. So it's
Okay.
really quite cool because the electronics and the components I use to make this, most of us have at our disposal in our schools, in our classrooms anyways. Lots of us nowadays have microbits
Right.
and things like that too, so super cool.
So it must just be a simple circuit. I heard a siren, a sound, and some lights, neopixels.
Yeah.
Yeah.
So all it is, we use simple circuits. So what I was thinking is that with simple circuits, you can actually program a microbit to respond if the circuit's opened or closed, right? So basically, by opening a door, you could, if that door is part of a circuit,
Right.
you could say when that circuit is opened, do
Okay.
whatever, right? And so
Okay.
I've got a speaker on this microbit to make some noise, like
Yeah.
a siren, right?
Yeah.
And I also have some neopixels running along it too, so that I can program those to light up when
That's
the door
awesome.
opens.
So all of your pins must be full on your microbits.
They are actually, yeah. So we've got the pin 0 running the speaker. Of course, everything is grounded. The pin 1 is my door, right? And pin 2 is running for my neopixels. So
Okay.
all of them are taken out by this.
Okay.
Yeah.
So when we were off camera and you armed it, what was that? What was the trigger? What was the event in order to arm it?
Right. So there's a number of ways that you can run a sequence of code with microbits. And for me, I wanted it to be quick and handy. So what I did is use the A and B buttons on the microbit.
Okay.
And so I said the event, as
Yeah.
you said, is basically on A, B pressed,
Right.
arm it.
Nice.
Right? And I used AB to disarm it too. So when the alarm was going off, I used the same event
Cool.
to disarm it too.
Nice.
Yeah.
Oh, that's really neat. Okay, so I'm guessing this is a really cool physical computing setup. So I'm guessing there's an elaborate piece of code behind the scenes, and then so what are we doing? Are we going to build it?
Yeah. So let's build it. I can take. Why don't we go quick through the code?
Sure.
Just to quickly go through the different components, and then we can go into a build and maybe make one of these for your locker.
Okay.
too.
Well, why don't we switch spots and
Okay.
I'll get the build started and while you're walking through the code.
Sure thing. So the code has 3 different components here. The middle part that we see here is on pin 1 released, and that's basically when the door is open. So the door is connected to pin 1. And really, if you look in here, we've got a sound that plays,
Mhm.
right? And then we're running our NeoPixel colors through here. So we're basically flashing our NeoPixels on and off with the sound that's playing. So
Did you have to assign a variable for both of those?
well, and that's what this top part is
Okay.
here. So in order to actually tell if the locker, the alarm is being set,
Yeah.
I had to run a variable too. So that variable I called alarm set.
Right.
And basically, when we start our microbit, we're setting the alarm to true. Alarm set is true, right? And then when pin 1 is released, then it basically says, oh, the alarm is going off, and runs this sequence of code. Now, in order to run Neopixels, we also have to create a variable too. So the variable we created, or that I created earlier, is, I called it lights, but you can call it anything. And basically, you define that variable as what you have for Neopixels. So up here, I've told it that my Neopixels are connected to pin 2. I've got 30 Neopixels total, and it's an RGB, a red, green, blue Neopixel.
And there's another kind of strip, RGBW, where there's actually 4 miniature addressable LEDs. It's important that you make sure what strip you have, because your lights, your colors might turn it all wonky.
Yeah, so I wanted to make sure, because I really wanted to have that purple color show up, because we all love purple. So I wanted to be sure that I had an RGB for sure instead of an RGBW. So then basically, anytime I want to turn those lights on or off or do anything with those lights, I have to call that variable. So here you see the variable called lights. I'm saying show color purple. And then the interesting thing with Neopixels is you always have to also add this block here where we say show. So lights show, so that it's showing whatever you want it to show. The interesting thing about these sounds too is that it's not very complicated at all. You can see when you click on that, this piano shows up, and you can choose any sound that you want. And for me, I just did middle C and low C to make those 2 sounds. So the second sound is down there. Right?
Nice.
And the neat thing about the while true statement is that as long as that door is open, it's going to continue to loop through or cycle through this sequence of code.
Okay.
Right? So we never really have to worry about it just playing once and no one knowing, oh, it's like, you weren't around, you missed it or whatever. It's just going to run through this loop as long as that door is open. So as long as that bad guy's trying to take your stuff, you're going to know, right?
A big thanks to our program coordinator, Kendra, for playing the nefarious villain, the felonious villain.
That's right. The brilliant bandit.
Play on words.
That's a good one, eh? And here's my on and off, right, with the AB. So here's the event in purple. If AB pressed, and then I've said, okay, if the alarm set is true, so that if the alarm is going off, I want to turn it off. So there's my AB press to turn off the alarm when it's going off. If the alarm is actually set to false, like it is now, I can actually activate it by pressing AB. I've given myself 5 seconds to shut the door, so it doesn't go off on me.
So if I wanted to arm this, I can reach in, press AB just once.
Yeah.
Okay. It would help if I could actually locate.
Yeah, it's tricky.
Oh, there they are.
Especially since we're kind of tucked away behind the locker.
Okay,
right?
and close it.
Yeah.
Nice.
And then that gives you 5 seconds to get everything situated and things.
The code looks really straightforward. For those of you who want to try out the locker alarm, just give us a week or so after we come back from World Maker Faire that we'll tell you about in a couple of minutes. And KO and I are going to work together to make sure that a full tutorial is posted on our Brilliant Labs/Learn site for you to follow. Yeah. And I guarantee you have most of these components sitting around. And for the buzzer, we're just using a piezo buzzer. It's a really simple piece of electronics. But if you didn't want to use the piezo buzzer and you wanted to use something a little bit more powerful, you can follow the directions on MakeCode and use headphones or that wouldn't be more powerful, but use a speaker, a Bluetooth speaker.
Yeah, a Bluetooth speaker or something like that. We have a few USB charging packs that you can actually power something externally, so you can get a louder sound and things.
Now, at some point, the electronics are going to become more valuable than the stuff that you actually put in the locker. But I guess that's just the principle of the thing, right?
One of the neat things about our code, too, just this final point, is that even though ours was kind of a bit elaborate, an alarm code can be quite simple, right? It's just that on pin 0 or pin 1 released, do this, whether it's play a sound or make lights light up, and really that could be it for you, right? So it's kind of neat how you can sort of layer this as sort of simple versions and work your way up to something a bit more complicated.
If you don't have Neopixels, that's fine. You can light up a single LED, or even the pixel display on the microbit would be an alert enough to
especially
tell
in
someone.
a darkened locker or something.
Yeah,
right?
absolutely.
Okay.
All right.
So that's that side of it. And of course, with any of these devices, there's two components. We have to, of course, tell the device what to do, but we also have to put it together and actually make it. So
I just brought up the overhead cam here, and
Right.
if we can quickly walk through the circuit. Do you have a secondary microbit already with the code?
I don't. So what we
Okay.
can do is just kind of put it together,
Okay.
and that'll be kind of enough for us today.
Right.
But I have two just in case we run into some issues. So what we have, all of the sort of components that we need for this build are here on the table. We have our microbit, of course. We also have a battery pack to help power the microbit and run the code. We have quite a few alligator clips to help us attach everything. And we have our two sort of external components. We have our buzzer, and we have our Neopixel strip here.
I love these new Neopixel strips because Adafruit has done a great job at pre-soldering some gator clips on them, and so they're just a direct connection, and it allows for really rapid prototyping for your electronics.
Yeah, we've been having a lot of fun with these things. We've just been sort of running through, iterating some different ideas, and the cool thing about them is you just snap them on, see if it works. You don't have to worry about soldering or anything like that.
Oh, that's good.
So to start off, whenever we're dealing with sounds, automatically the sounds go through pin 0. So what we're going to do is connect an alligator clip to pin 0, and then we're going to use our buzzer.
And with the piezo buzzers, there's no polarity. So
That's right.
Sometimes when you're troubleshooting and something doesn't go right, you're thinking, oh, I've got the polarity mixed up on the piezo. There isn't. It means that something else is going on.
Mm-hmm. So that's a very good point. Yeah, so because I didn't really pay attention to anything on this buzzer when I was connecting it. But there's pin 0 connected, so we're going to be able to play our sounds. Now, the activation for that sound is the door opening, and we have our door connected to pin 1.
I've got some aluminum foil in my locker.
Oh, okay. Well, let's go through this entire process.
Well, just really quickly, yeah.
Yeah, why not? So I'm going to actually attach one of these alligator clips to pin 1. Now the second thing I'm going to do, pin 1, all of these pins need to be grounded. And I've sort of taken up the ground pin by this alligator clip that's running to the buzzer. But we can share this. We can set it up so it's a common ground for all of these devices or these peripherals. And so what I'm going to do is just sort of clip this alligator clip that I'm designating as ground to the clip that's already clipped onto the microbit. And for now, because this is our door, I'm just going to clip these together. Right?
Oh,
so
okay.
We can just keep it tidy, right?
So me folding up tinfoil is really futile.
No, I think it's awesome.
Oh,
Why don't
you
we
think
do
it's
that?
awesome?
Yeah,
Okay,
I think it's
that's
awesome.
great.
Because it gives us a good visual. So now, the last thing, we just have our Neopixel strip, right?
Yep.
And so we have, now the difference with the Neopixel strip is that we have three wires coming off of it. We have our ground, which is the black, right? We have our signal, which is this white guy. This is what sort of switches it on and off or sends the information. And then this is the power for it, this red one. So that basically ties up the rest of these pins. So we're going to take the white one, connect it to pin 2, right? We're going to take the red one, connect that to where it says 3V. That's our voltage on the microbit. And so when we do that, it's going to receive power from our battery pack. And then the ground, of course, just goes on with the rest of them. And I'm just going to clip that onto the one that's there.
Nice.
So now we have all three, and I'm just going to maybe lay these out so that it's easy to see.
And it's a whole mess of wires. And we've got a focus issue on our overhead cam that we're going to have to address for our next YouTube Live. But we've got all of these wires. And keep in mind, we can simplify this setup a little bit before we install it. We didn't for our purposes. But after you have your first prototype, anyway, don't be embarrassed if there's all kinds of wires. It is just a prototype.
That's right.
And you can refine it all kinds of different ways.
Yeah, we always say proof of concept.
That's
right?
it.
You're not worried too much about the aesthetics of it at the moment. You're just worried about seeing if it does work.
Yeah.
Right. If your logic actually makes sense. And then different things that we were thinking, if we had the time, we could 3D print enclosures for it, or even laser cut enclosures.
Yeah, absolutely.
Even using cardboard, right, to build an enclosure for it.
Yeah, that's right. So we don't have the code on this, but if we were to follow this all through and upload the code, it would be a simple drag and drop solution.
That's right. Yeah. So if we were to, let's say, this piece of aluminum foil is on the door itself, and this is on the frame of your locker. When the door is opened like this, the circuit's opened. When the door is closed, there's a contact, so the circuit is closed, and so it responds to those actions accordingly.
You know what?
Let's do it.
Let's do it. Why not?
I was thinking the same thing.
Okay. So as long as our program doesn't freak out here because we have many peripherals hanging off these dongles, we're just going to use the USB micro and slide that in. Can I say one other thing that I love about the setup that we wouldn't have been able to say 3 or 4 years ago when we started these things? This is all going to be wireless. All kinds of wires, but it's not tethered to a computer.
That's right.
It's not tethered to an electrical outlet. It can be battery operated and installed in your locker without worrying about...
it's all self-contained,
it's
right?
all self-contained.
Yeah, that's a really good point. A lot of, and there are lots of devices that we use that kind of follow the same logic and things like that, but they do require you to be connected to a computer or something. And the Microbit, Circuit Playground Express, those are all really good examples of devices that we can kind of
use locally.
Yeah, exactly.
So I'm just hopping over into our code section, and I've downloaded your code. Hopefully we haven't done any major alterations to it. The other thing that as soon as you start using your Microbit and your coding, it just pops up as a flash drive, as a USB key, and you can copy and paste just by dragging and dropping. And if you're using a Windows 10, an updated version of Windows 10, you can also download a helper app, or you can download an offline version of the Microbit compiler, and once you hit download, it just automatically goes over into the Microbit.
Mm-hmm.
Okay, so here we go. Downloading.
All right.
There we are.
So let's see if we can figure this out. Now,
I really wish this overhead cam was in focus.
Maybe
your head is it? Yeah.
My head's in focus.
Yeah, your head's in focus.
Not all the shiny.
Yeah.
Do you want to do the door?
Sure.
Let's see if we can do this.
All right. Ready?
Yeah.
Look at that.
We did it. So now let's deactivate that. Boys, trying to get in focus here, eh? I'm going to set the alarm, turn the alarm off.
Okay.
AB shuts it off, and then
AB again.
Arm it. So let's arm it with the door open.
Oh,
so
sorry.
We can see. So it's armed, and then close the door, and then open the door. Let's see if it'll go off. That's
it. That's awesome.
And we're done.
That's awesome. All right, so listen, I am conscious of the time. We don't want these to be longer than half an hour, and we were getting really close to that time.
Okay.
So long story short, we've created a Microbit-enabled, Neopixel illuminated, buzzer, audio, blah, blah, blah. We've made a locker alarm that's sure to impress your friends and your teachers around your school.
Yeah, and the really cool thing is that these kinds of devices, again, we've called it a locker alarm. We're using it in a locker, but this can be a door alarm. This can be a drawer alarm in your desk or something. Anything at all that you want to keep safe, you can protect with this kind of logic and with the Microbit and all of these peripherals.
Right? Absolutely.
Yeah.
So really quickly, I've switched back over to our code screen to hopefully update the website for makerfair.com because on Thursday, most of the Brilliant Labs team is traveling down to Flushings in Queens, New York City, to attend the 8th annual New York Maker Faire. And what do you expect us to see there?
Oh, everything. This is one of the best professional learning opportunities that all of our teachers, all
It's
of our
incredible.
administrators, all of our Brilliant Labs team. We're going to get so much out of this experience. You go down there, and every year there's something different that inspires you. That you sit there and you run into people that you don't even know, and we're all makers down there, and inspiring each other on different creations that we've made, and teachers, and even local talent like yourself that's going to be there. Inspiring everybody on what's been happening here in New Brunswick too, presenting too.
So if you're interested in all things Maker Faire, make sure that you follow us on Twitter. We're going to be hanging out at Maker Faire all weekend, and here we are. So the website's working
there
now.
It is. Yeah.
So Friday is the Educators Forum. And I've got the pleasure of representing Brilliant Labs and speaking there, but my presentation is far diminished by the talent that's speaking beside me and before and after. It's an incredible lineup.
Yeah, it's an incredible opportunity for everybody that's going.
Yeah.
And we're quite excited.
Yeah.
There are quite a few people from our neck of the woods going to be there representing in the purple shirts.
The purple shirts, that's right. Well, listen, everyone, thank you very much for tuning in to our first YouTube Live of the 2018-2019 Brilliant Labs school year experience. We got to end it there.
Yeah.
All right.
Stay brilliant, everybody.
Stay brilliant. Oh! Mr. Keys, why don't you come here? Thank you very much. Do you want to pop that on your head?
I do, actually.
Okay, so here's a huge reminder. Our first Innovation Challenge is launching. Well, consider this the launch. And it's our Brilliant Labs Halloween Hacking and Animatronics Challenge. So long story short, if you have an old Halloween prop laying around your house and you'd like to make something out of it, make it do something, make it move, make it light up, make it play a sound file, make sure that you check out our website and see all the details for that challenge.
Definitely.
They can stay brilliant with that.
Yes, they can. This guy can too. He's pretty brilliant already.
You're pretty brilliant. Thanks, folks. We'll see you again.